Hello students. We are on lesson 3 agents of erosion. We are going to proceed further. Now, these are some terminologies which have been used in the beginning of the chapter over and over again. That is corrosion or abrasion. We have already spoken about in the textbook. It involves the scratching and polishing of the surface of bedrock by the particles which are moving onto it. And they've given an example of sandpaper. Now here, uh, corrosion or abrasion is the grinding of rock fragments carried by the river against the bedrock and banks of the river. This action causes the channel to widen and deepen. This grinding is most powerful in flood time when large fragments of rocks are carried along in the river bed. Attrition. Now, attrition also we have done. It is when rocks and pebbles bump into each other and break up into smaller fragments. During transit, means during movement from one place to another, materials reduce in size. Rock particles become more rounded. This is the collision of rock fragments in the water against one another. The rock particles are broken into smaller pieces and become smoother the longer the process continues. Certain terms have to be kept in mind wherein the processes of erosions are concerned. There are different processes of erosion what we have done other than these two what I'm talking about, that's plucking, solution. Then there are different types of processes of transportation, saltation, traction, then lateral erosion, vertical erosion, deflation, drilling, all of that. Now, these all terms you need to know over and over again. So I'm starting off with explaining these two terms which are very important in this lesson. Now, solution or corrosion is the process by which, when we talk about solution or corrosion, it is the process by which river water reacts chemically with soluble minerals. There are already minerals present in the water and they react chemically with the water in the rocks and dissolve them. An additional process is also at work caused by the force of water itself, known as hydraulic action. This is another term which has been repeated in each of our lessons, each of our lectures basically, and these things you all have to know it very well. In this, what happens in solution? In this, rocks are dragged away from the bed and banks by the force of the running water. When water from a fast moving stream enters the minute cracks which are present in a rock, the pressure exerted, the pressure put on it weakens, and then when it becomes weak, it eventually breaks up the rock. Here again, solution, when we talk about it, in the textbook it is said the material which is carried in water in a dissolved state, and they've spoken about limestone or similar soluble rock is present, the amount of dissolved load in water is greater. Now, besides getting to the sea, the three processes a river is involved in are the wearing away of the river banks. These are the three processes, students, of a river is involved in are the movement of rocks and silt from one place to another, the settling down of the river's load. Now, river is, what is a river? It is basically an agent of erosion, and in agent of erosion, the different processes of erosions are what, students? The different processes of erosions are plucking, that happens through glaciers. I repeat, abrasion, um, attrition, and solution. It happens through wind, glacier, sea, and waves. As well as solution, deflation, drilling is an agent of erosion. An agent of transport is traction and saltation, which we have already studied. An agent of deposition also we have done. Now, what is agent in simpler terms? Agent in simpler terms is something that is capable of causing a certain effect. Agent is something that is capable of causing a certain effect. Erosion, I've already told you what is the meaning of agent, erosion, and what is the meaning of agent now. It is something that is capable of causing a certain effect. Look at the way erosion, step by step. What are the three processes? Erosion is happening, transportation takes place, and deposition. Deposition is settling down of those sediments where they are carried. Now, certain terms which we need to know very well. There are certain terms which we need to know. Bed load. Now, what is a bed load? It is amount of water passing a point in the river in a specific time, usually in cubic meters per second. Now, students, these terms, they are repeatedly there in your lesson. So, these terms, the meanings of these terms, you need to know. It is only for that purpose. So, if you know the meanings of these, you will be able to answer and understand your questions properly and your lesson also properly. When we talk about bed load, the amount of water passing a point in the river in a specific time. What is a confluence? It is angle of a slope. Deposition, it is area in which a river actually flows, the sides and bed of the river. Discharge, area of land drained by a river. When we talk about discharged or drainage, it is the area of land drained by a river. Drainage basin, boundary or edge of a river basin. Erosion, that is downward erosion by a river. Lateral erosion, smaller river streams which join the main river. Mouth, speed of which a river flows. River channel, starts of a river. Source, the material carried by a river. Tributary, wearing away the land. Now, students, these are not definitions which are, you have to match them to understand. This is a small, I can say this is a small homework sort of a thing which you all can understand. You'll have to match these terms with the specific definitions. Definitely, discharge is not area of land drained by a river, or mouth is not speed at which a river flows. Mouth is start of a river, for example. Erosion is wearing away of the land. So these two I have helped you all. You'll have to solve this. I'm just repeating what is written in definitions and for you all to understand. Why am I saying that? Because these definitions are not in order. You have to connect them with the specific terms. Vertical erosion, we have already studied, where a river meets the sea. Now, vertical erosion is not where a river meets the sea. If I suppose have to define vertical erosion, in the previous class, I had told you that this is basically vertical erosion. When does it happen? I spoke about headward erosion, lateral erosion, downward cutting or downward erosion. So, all that in that itself, you will get your answer. Vertical erosion, watershed, where two or more rivers meet. Now, watershed, common sense, it's not where two or more rivers meet. These are very important terminologies which can help you all understand the lesson very well because they are repeated terms which have been mentioned here. Now, here, when we talk about sand, sand also gets deposited along the sides of the headlands. Such deposition extends parallel to the coast, means it is parallel, it's going, deposition is happening parallelly to the coast from one headland to another. That is transportation. Over a period of time, these deposits extend over long distances. So it's like extensive over a long distance and develop into a bund or bar. It develops into a bar that protrudes. What does protrudes mean? Protrudes means sticking out into the water at some distance away from the beach. These are called sandbars. Along the coast in Maharashtra, we can find sandbars at Srivardhan and Revadanda. The sandbars offer the first protection against storm or tsunami by absorbing most of their destructive force. So these sandbars basically protect against a storm or a tsunami. How? By absorbing most of their destructive force. They absorb all that destructive force. Between these sandbars and the land, a part of the sea gets enclosed. The water in the enclosed sea is brackish. What does brackish mean? Brackish is not something related to color. It is slightly salty. Brackish means slightly salty. This brackish water is called a lagoon. I already in the previous class I had told you all what a lagoon is. As they get separated from the sea, these lagoons are like salt water lakes. In your junior classes, you all have studied about the Chilka Lake in Orissa as an example many a times, and the Vembanand Lake in Kerala are examples of lagoons. So they can, as an objective question, they can ask you all that give us some examples of uh, some lagoons in India. So Chilka Lake in Orissa and Vembanad Lake in Kerala. The Chilka Lake in Orissa becomes freshwater lagoon during monsoons. So a freshwater lake or a freshwater lake lagoon or a lagoon is in Odisha. Sometimes such sandbars are not separated from the mainland and they extend into the sea. They are known as sand spits. Sandbars and sand spits may get separated from the land. So it is possible that these sandbars which are formed and spits can get separated from the land. The uniqueness, what makes it stand apart? Uniqueness of coastal areas. Compared to the other agents of erosion, the work of sea waves goes on ceaselessly, means it continuously goes on. So compared to the other agents of erosion, the work of sea waves goes on ceaselessly. Therefore, its effect becomes apparent. What does apparent mean over here? Apparent means it becomes clear within a short period of time. Erosion in some part and deposition in the adjoining part keeps on taking place constantly, means simultaneously erosion in some parts and deposition in the adjoining part takes place constantly. It's constant. The beaches and bars, which are normally the products of deposition, are subject to erosion. Coastal regions are always vulnerable to the risk of getting submerged. Now, the coastal regions, if I can say we go to coastal areas, if I talk about Maharashtra particularly, see the belt of Konkan, it is coastal. Ratnagiri, all these are coastal areas. So, coastal regions are always susceptible, vulnerable to the risk of getting submerged due to the increase in sea level. If there is increase in sea level, these coastal regions can get submerged. Coastal regions are also the regions of high population density. Yes. Now, if you see, there's a lot of high population density in these regions for various reasons. Therefore, the coastal zone management warrants serious attention. Now, if you've ever been to the beach, you've been on a coast. The coast is the land along a sea. The boundary of a coast where a land meets is called a coastline. Now, students, simple thing. I know most of you know these things probably. I assume some don't know. So now what is a coastline? The coast, it is a land along a sea. So that is the boundary of a coast where the land meets water is called the coastline. Waves, tides, and currents help create coastlines. What helps create coastlines? Waves, tides, and currents. When waves crash onto the shore, they wear away at erosion is like wearing away. They wear away at or erode the land. See, erode means wearing away. Now, whatever it wears away, probably it's like if wearing away the soil. But they also leave behind little parts of the sea, such as shells and dollars, sand dollars, seaweeds, and hermit crabs. Sometimes these objects end up as more permanent parts of the coastline. So we know that the waves, tides, and currents create coastlines. So when there is erosion happening, they leave behind certain depositions in the form of seashells, sand dollars, seaweeds, and hermit crabs, and they end up being permanent. Coastal changes can take hundreds of years. Any change which is happening can take hundreds of years. The way coasts are formed depends a lot on what kind of material is in the land and water. The harder the material in the land, the harder it is to erode. Coastlines of granite, a hard rock, stay pretty stable for centuries. Now, we'll understand this, page 36. On a global level, when we look at it at globally, global is world. Wind is less effective as an agent of erosion than running water, waves, groundwater, or glacier. So, as compared to running water, waves, groundwater, or glacier, wind is less effective. But it is a significant agent in the deserts. So, in deserts, which agent of erosion is very significant? Wind. Aridity, that is, in such areas, rate of evaporation is greater than the rate of precipitation. It is greater than the precipitation. Precipitation is what falls from the clouds in the form of dew, hay, all of that. Sparse vegetation, cover or absence of trees. Presence of dry loose materials at the surface. Now, here they are saying which are the conditions which are necessary to become more effective. A wind velocity high enough to pick up and move sediments. Strong winds blow frequently in arid regions. These movements frequently these movements of the wind pick up loose surface materials and transport them with wind currents. Deflation. Now, what is deflation? It is like if I can say, deflation in geology is like it's erosion by the wind of loose materials from flat areas of dry, uncemented sediments, uh, such as those in deserts and floodplains. So it's like a decline or a removal of the solid particles in desert areas. Deflation occurs when wind blowing fast enough in swirling motion over an area of loose sediment. It is able to pick up and remove small fragments of rock. This erosion can produce shallow depression. Shallow means at surface level, not very deep, which can vary in diameter. So they can vary in their size. Diameter from a few centimeters to a few kilometers are called deflation hollows. The Qatar Depression in Egypt is formed in this way. It is around 300 kilometers long and 135 kilometers wide. Its depression is 133 meter below sea level. Where the land surface is exposed, wind can polish. The land which is exposed only, that can be polished, the rock surface, through abrasion, through the process of abrasion. That's why I started my lecture with abrasion, because these terms are going to be repeated over and over again. Abrasion carves the windward side of rock into smooth sloping surface. These rocks are called ventifacts. Now, um, I will tell you more about ventifacts, but what are ventifacts? They are, if you look at figure 3.3, this is a ventifact, a pebble or cobble that has been grooved or polished by erosion. That's the action of wind, erosion by wind. When it is these pebbles, they have been polished and grooved. That is called a ventifact. Abrasion also contributes to formation of mushroom rocks. Figure 3.3 shows how a mushroom rock looks. So, the high rising rocks in the path of the wind are attacked by the sand that moves with the wind. Winds and the particles they carry attack the base of an individual rock. Now, these particles carry and attack the base of an individual rock. The larger top part is not eroded as much as the basal part. The particles at medium height are smaller and their velocities are high. Hence, their impact is more. As a result, the portion of rock at medium height is eroded more and the rock as a whole gets the shape of a mushroom. So, as a question, you can be asked that how does a rock get the shape of a mushroom? Through which processes? Or explain in detail the formation of a mushroom rock. Now, in areas where hard, soft rocks are found, the softer rocks get more eroded faster. Very obvious. The eroded portion of softer rock, the wearing away of that softer rock portion appears like an elongated ridge, and harder rocks appear as elevated portions. Now, elongated means they get elongated means they become long and thin in an unnatural way. Elongated ridges and harder rocks appear at elevated portions. Elevated means what? It's like it's at a higher portion, at placed higher. A yardang, that is figure 3.3. A yardang is the remaining part of a ridge where rocks have been eroded. Now here see, look at the ventifacts. Multiple faceted pebbles, ventifacts, are formed from dolerite rocks. This is a type of a rock in Taylor Valley, Antarctica. This group of rocks are likely started as single rock that over time has broken apart. The wind has eroded. It is through to the erosion of wind, the surfaces that appear gray, while the reddish part of the rock is simply the weathered surface of the rock patina. The insect picture shows another example of rock breaking apart in the place and being eroded by the wind. Now, I had already spoken about attrition. In attrition, what happens, students? What is the meaning of attrition? Attrition is when rocks and pebbles they bump into each other and they break more into smaller fragments. So they become more rounded. The identification of this process of erosion called attrition is where rock particles become more rounded. So attrition reduces the size of the particles as they dash against each other, mutual bouncing. Transportation is carried out by winds where large size particles at lower heights and finer particles at moderate heights, not at greater heights. So large particles which are there at lower heights and fine particles at moderate heights through traction and saltation. Now again I repeat, what do you mean by traction and saltation? Traction and basically traction and saltation is process of transportation. Over here in traction, what happens? The material is transported by rolling, pushing, and dragging along the surface. And in saltation is where pebbles and gravels, um they are too heavy to be carried away. So they move forward by leaps and bounds. So in traction, they roll and they get pushed and they get dragged. In saltation, they move forward by leaps and bounds. So this is what happens. All materials transported by the wind are deposited. Coarser material is often deposited in the shape of hills called sand dunes. I will be showing you all how does a sand dune look, what does it mean, what is the importance. I'll try to put in all the information which I have so that it's easy for you all to understand. Fine grained sediments such as silt can be transported in suspension over long distances from its source area. These deposits are called loess. Loess. That is, what is that? That is like layer of fine material which is rich material in loess. It can be formed by glaciers. It can be formed by glaciers. Now the types of sand dunes. Sand dunes are classified according to their shape and wind direction. So how are they classified? With shape and the wind direction. Barchans are crescent-shaped dunes. Barchans are crescent-shaped dunes. They form where supply of sand is minimum. Due to an obstacle in the path of wind or due to the lowering of its velocity, the sand moving with it gets fropped at some places. The Bartian slope, when we talk, it is the crescent-shaped dune faces with the wind is gentle, whereas the opposite slope is steep. Such hills can be seen in larger numbers in Great Indian Desert in Rajasthan. Now, here we are talking about the work of winds. What work does the wind do? We already know that wind is less effective as an agent of erosion as compared to the other agents of erosion, that is by water, glacier, and waves. So, and what are the following conditions which are required for it to be effective? What all processes? How a mushroom rock is formed? What are ventifex? What is a yardang? Now, there are different types of sand dunes. They are the crescent shape we spoke about. Now, what are the longitudinal dunes also we will talk about. The loess deposit from the loess plains also we'll talk about. These are the different types of sand dunes what we are going to discuss about. So, this is basically covering the work of the winds.